The Voyager 1 spacecraft, which has been in space for more than 40 years, made an important announcement during its trajectory. In addition to its original mission, it exceeded all expectations as it was only expected to last 5 years. Voyager 1 has now detected the presence of 300 unknown objects passing through space. This discovery completely changed our understanding, because these objects were found to be plasma from the explosions of giant stars millions of years ago. Join us on this journey through space to find out what these objects discovered by Voyager 1 are all about. Unlike previous years, when we could only analyze data from our own solar system, thanks to the innovation provided by Voyager, we now have access to data that no longer exists. In August 2012, Voyager 1 officially left the solar system, crossing the heliopause. However, this milestone was not easy to achieve. As the probe moved farther and farther from the sun, the amount of sunlight available to the propulsion devices and systems was greatly reduced. The spacecraft's power is produced mainly by 3 radioisotope thermoelectric generators, which convert the heat produced by the natural decay of plutonium-238 into electricity. As the heat output of thermoelectric generators decreased over time, the available power decreased, affecting the operation of many shipboard systems, including scientific instruments, data transmission, and communications. To conserve energy, non-essential systems and instruments are disabled or put into sleep mode. As power decreases, Voyager 1's critical systems must be optimized or shut down to extend its life. In its current state, it won't work much longer, although it is still very valuable to us. The great distance between Voyager 1 and Earth presents a major challenge to maintaining effective communications. As the spacecraft entered interstellar space, Voyager 1's signal strength weakened. It takes more than 21 hours for signals to travel from Voyager to Earth. A weak signal combined with interference from background noise makes it difficult to send and receive information. In addition, the temperature change from the heliosphere to interstellar space exposes Voyager 1 to different thermal conditions. In the heliosphere, the spacecraft was closer to the Sun and experienced high temperatures, while entering interstellar space it encounters extremely low temperatures. The Voyager 1 probe is equipped with dust detectors specially designed to measure the density of interstellar dust in deep space. However, communication with Voyager 1 is hampered because NASA's global antenna system has limited resources to receive mission signals. This results in fewer opportunities for communication than before. However, an exciting discovery recently occurred amid the data stream. Voyager 1 detected a fascinating anomaly: the presence of 300 unknown objects traversing interstellar space. The discovery has baffled scientists around the world because it challenges our understanding of the cosmos. Are these objects the remains of ancient passing celestial bodies, the remains of distant star systems, or the presence of previously unknown phenomena? While normally the information transmitted by Voyager is easy to decipher, in this case the information was encrypted, raising many questions but few answers. But the strangest thing is that, despite the strange nature of the data, Voyager 1 seemed to work flawlessly. Its communication link with Earth remained intact and the signal remained strong, allowing valuable information to reach NASA without major problems. Interestingly, none of the ship's defense systems were activated, indicating that there was no immediate threat, ruling out a possible attack, what can cause telemetry data to become blurry or look inaccurate. Could it be due to disturbances caused by cosmic phenomena such as radiation or high-energy particles? Or is it possible that it is a completely unknown phenomenon that defies our understanding of space? The only way to be sure was to carefully analyze the many possibilities. The NASA research team analyzed the systems in depth, taking into account the effects of cosmic rays on electronics and the possible effects of temperature fluctuations on their sensitive instruments. It's possible that something happened just before Voyager entered the heliosphere, and natural changes along the way caused problems with data transmission. But Voyager 1 wasn't exactly in an area where these natural changes were concentrated enough to cause problems, so that didn't seem to be the answer. The team also investigated the complexity of Voyager 1's communication systems, examining possible distortions caused by cosmic noise, interference, or even subtle changes in its orbit. The search for answers led to a careful analysis of all these possible factors. The spacecraft systems were studied considering the effects of cosmic radiation on electronic components and the possibility of temperature fluctuations affecting its sensitive instruments. While selecting checkboxes in a list may seem like a simple task, there was actually a lot of work involved. Therefore, this investigation was not immediate, but took weeks. The team developed advanced data processing techniques, improved innovative algorithms, and ran simulations of various scenarios to identify the root causes of unusual anomalies. Then it was the only way to find out the cause of the problems. All this effort was not in vain. After months of receiving encrypted data from the spacecraft, scientists and engineers were finally able to restore the clarity and reliability of the data from the far reaches of interstellar space. The cause of the problem was Voyager 1's Attitude Articulation and Control System, ACS, specifically the boat's computer, which was supposed to be inactive. Surprisingly, it was discovered that ACS began to use the computer, although it had been inactive for years, thus corrupting the data being transmitted. However, the rest of the spacecraft remained operational and continued to collect data. Engineers acted quickly to determine the cause of the problem and sent a command to Voyager 1 telling the ACS system to switch to the correct computer to send telemetry data. Although the solution was low risk, it required a lot of patience because the distance between Earth and Voyager 1 caused a significant delay. It takes nearly 22 hours for radio signals to travel back and forth, so the troubleshooting process required careful coordination. There was one problem to consider, though. Voyager 1 was built decades ago and has worked perfectly well until now.
Therefore, finding a solution to the current problems would be a big challenge. They had to go through some manuals from 1970, and that's exactly what they did. After careful research, they found a simple solution to the problem by resetting the system responsible for data transmission. So they managed to fix the problem without touching any other part of the ship. The design team's experience and dedication played an important role in restoring clarity to Voyager 1's communications. Their efforts emphasized the importance of leveraging past knowledge and combining it with current technology to meet the challenges of space exploration. Voyager 1's journey was not only a testament to human wisdom, but also a source of constant scientific discovery. As a spacecraft moves through the unexplored expanse of interstellar space, it provides valuable information that deepens our understanding of the universe. The discovery of 300 unknown objects, which are plasma from the explosions of ancient stars, has provided a rare look at cosmic events millions of years ago. These findings challenge existing theories and open new avenues of research, potentially changing our understanding of how the universe has evolved over time. Voyager 1's continuous stream of data allows scientists to study these interstellar phenomena in unprecedented detail, helping to better understand the dynamic and complex nature of the cosmos. In addition, the challenges facing the Voyager 1 mission emphasize the flexibility and adaptability necessary for space exploration. Degradation of energy sources and problems with communication systems highlight the need for robust engineering solutions and innovative problem-solving methods. As Voyager 1 ventures deeper into the unknown, the mission team must constantly adapt to new conditions, often using decades-old technology and knowledge to meet today's challenges. This combination of historical understanding and modern ingenuity is critical to maintaining the functionality of the survey and ensuring the continuity of its scientific contributions. Success in solving the recent data corruption problem is an example of how sustained effort and careful analysis can overcome seemingly insurmountable obstacles in space exploration. In the future, the Voyager 1 mission will serve as an inspiration and model for future interstellar endeavors. As humanity turns its attention to more ambitious projects, such as sending probes to other star systems or establishing a human presence on Mars, the lessons learned from Voyager 1 will be invaluable. The mission demonstrates the importance of long-term planning, the ability to solve problems from great distances, and the need to maintain a strong support infrastructure on Earth. Voyager 1's legacy is measured not only by the data it collected, but also by the profound impact it had on the field of space exploration. Its journey continues to inspire scientists, engineers, and dreamers, proving that with dedication, creativity, and determination, even the most distant and difficult goals are within our reach. Engineers suspect that the anomaly using Voyager 1's malfunctioning computer was caused by a faulty command from another system on board. This hypothesis points to a fundamental problem with the spacecraft's complex computer network. Mission leaders remain cautiously optimistic, stressing that the incident does not threaten Voyager 1's long-term well-being. The spacecraft corrected the error and resumed its mission as soon as the correct computers came back online.